Good afternoon, everyone. So I think in the last discussion from IOM, like it was highlighted how important the security aspect is. So by introducing this new concept of zero trust, so we are trying to make the hacker's life hard. So let's see, in this topic, I will be talking about why this particular concept was brought, and then what it is, and what are the core principles around it, and what are the practical examples of it, and end of the day, how as engineers we can practice this to make the our security posture of our organization as well as our customers successful. So if you are familiar with the deployment architectures, maybe if you have worked, look at some 5 years ago, this is a traditional deployment architecture that you see. So basically you see there's a trusted internal network, and there's a DMC, and then the attack surface, that's the internet, right? But what is the problem with this particular deployment pattern? So you will see this is basically based on trust. So we assume there's an implicit trust within the internal network that the resources in the internal network is accessible for the users internally, and probably you will not enforce high security standards such as encryption at the network level, database level, and so on, right? Maybe you will not have fine-grained access control policies applied to your internal resources because you assume there's an internal trust within your boundary. But what happens with the movement of the digital organizations, what happens is now employees are going to work not from a single office, they are working from multiple offices, they work from home, and sometimes they use multiple devices to access these resources in the enterprise. So now what happens to our this trust-based deployment architecture? So there's no any more trust that you can have. So basically these trust boundaries are dissolved, no longer exist, right? So that's the problem that we are trying to address using zero trust. So basically, zero trust security approach was needed because with the introduction of these modern technologies and how the employees are and our partners and users are going to access the enterprise resources, now the landscape has changed. So this is why you need to have a separate rethinking about new security concept to address these concerns. For example, if you get access to one of the internal resource by a attack through a web application or an issue with one of your application, then they have the access to all the other resources unless you have higher security in place, right? So that is about the lateral movement within your enterprise where they get access to the one particular set of resources, and then they can move to the other network segment too, and all of your resources are compromised. So zero trust is not it's a very new concept. It was started basically in 2004, and at that time it was called as deperimeterization, basically trying to break these zero trust boundaries. And then Forrester came up with this term zero trust, and then later Google came up with a product called Beyond Corp in 2014. And finally, National Institute of Standard and Technology came up with the paper to basically implement the zero trust as a proper mechanism to secure your basically organization and improve the organization security posture. So with that, we are moving to what is zero trust. So zero trust is not a product or a service that you can buy from outside. It's not. It's a security model. It's a concept or a strategy and a framework, where the key thing is you trust nothing by default. But in the previous model, you had the implicit trust within the organization that, but in this model, trust is considered as a vulnerability. So that's what we say as never trust, always verify. You have to make sure each device, each user, each request that is trying to access your enterprise resources are properly verified, until it is proven, otherwise you consider it as a threat. So, and another principle of this is like you assume breach. You assume that all your enterprise resources are now like basically vulnerable to the outside world. So there's no boundary of like trust in here. So that's the key principle in the zero trust. So we no longer like have the implicit trust. We have to verify explicitly at each and every request. And then there's the other high level like key concept of like least privilege access principle. You are very much familiar with this in terms of like just enough access least privilege principle, but now we have to make sure we apply the other key principle also, like just in time privilege access control. That is about like when you're going to access a particular resource, you are going to access it for a certain period, only for a limited time to get your job done. So with that, so this is the what is zero trust architecture means. So the previous one is about the concept or the paradigm, but this is about the practical implementation of zero trust concept as a cybersecurity plan. So in a cybersecurity plan, what we have is we have enterprise resources which you want to like securely make it available for your users to access, only for the authorized users. For the time being they need it, and for the level of access. For example, if it is just only for reading purpose, they should be allowed for the read purpose, not for the delete, right? And then how this is implemented is like from the on the right-hand side, on the left-hand side, we have the enterprise resource, and in the middle, we have the policy enforcement point. So the policy enforcement point is the one that is going to basically verify the request coming to access your enterprise resources. So basically, the job of the policy enforcement point is to like basically establish a connection between the subject and the enterprise resource, and basically monitor that particular connection. And then in certain cases, like if you terminate the connection, so that if there's a malicious activity, then you get a like notification from the policy administration point to terminate it. So the job of the policy enforcement point is to basically manage the connection and terminate it as needed. So then policy enforcement point basically listening to the policy administrator and taking decisions. So this entire part is policy decision point. We have the policy engine and the policy administrator. So those who are familiar with the SACML terminology, like basically extensible access control markup language, it has the same like principles or the component in that as well. So the policy engine is the one actually going to validate whether this request should be allowed to or whether this resource should be granted for this particular subject, right? So that will generate three decisions. One is either it is allowed or denied, even like reward the access for this subject to access the resource. So basically it's not like a one-time thing, it can revoke the permission as well. And then policy administrator's job is to basically translate that decision to the policy enforcement point as a like command. For example, it is going to say, establish this basically, let's say, session between the subject and the enterprise. Or basically continue this session between the subject and the enterprise. So deny this connection or terminate this session. So that's the jobs of the policy administrator. And then, so we have discussed what's in the main, but the key difference in zero trust architecture is about like you are going to have like dynamic policy. It's not that static access control list that you find, or it is like going beyond the simple role-based access control. Let's say like you have different inputs from to this policy engine to take decisions. Let's say the first one is the data access policy. It's about like there are like resources in the enterprise, and then like there are subjects, and how do you map these subjects, or how do you grant? What are the policies you have defined to grant these resources to the different users or roles or groups and so on, like simple RBAC, right? On top of that, we have the like public key infrastructure also in place. That's where like when the each and every users, devices, and resources are attached with certificates, so we need to know whether the certificates are revoked or whether it is like still valid, right? So that sort of information also fed into the policy engine. And next thing is like identity and access management, when that's where actual user identity is managed. In certain cases, like device identity also managed in the same identity management system. And then we have the security information and event management system, which is monitoring end-to-end process of like basically the traffic between the subject to the enterprise resource, basically how they access it, whether there are vulnerable like access patterns, and then basically feed that information back to the policy engine so that it can take very dynamic decisions about what's happening in the enterprise. From the other side, we have the continuous detection and mitigation system. This is applicable for mostly for the devices. So we have to take the decisions on what is the device this is being accessed, right? And then what is the patch level of that device. So we need to know these details to make sure this policy engine can take timely decisions based on the user accessing, whether it's accessing from like its own device or it's within the network or from different geolocation and so on. And also, depending on the industry compliance, like HIPAA, we will come up with our own rule set as well, like basically it translates to data access policies. At the same time, like we need to know about the threat intelligence, like what are the latest security vulnerabilities present. And since we have a knowledge of what are the like enterprise resources and what's the state of the devices or the users, and then the vulnerability status, then we can take very accurate decision by the policy engine. So with that, I'm moving to what are the key tenets of like coming up with previous architecture. So we are trying to assume like every data source and computing devices, any device that is connected to the network is considered as a resource. And also, irrespective of where the user or the device is connecting, trying to get the access to the resource, we have to make sure this network communication is fully secure. So what that means is like you need to apply like network level encryption and application level, like transport level encryption and so on, that make sure that end-to-end communication flow is secure. So the next thing is like you grant this resource per like session basis. Like you are not like going to grant it for 1 hour and 2 hours, maybe like it's a couple of seconds or minutes. And also the key thing, other key factor is about dynamic policies. It's not about like the simple RBAC. It goes beyond like multiple factors as we discussed in the previous slide. And also the data integrity. Basically, if your device is vulnerable, then like you need to patch it immediately. So those things are considered here as well. And by default, yes, like authentication or authorization, like you have to make sure you follow multi-factor authentication and so on. And finally, about monitoring. So then this US National Security Agency came up with like 7 pillars of zero trust architecture. So it's talked about like 5 major pillars and then 2 foundational pillars. Those are the users, device, application and workload, data, and the network and environment, and those are the 5 key pillars. And after that, we have foundational pillars as like visibility and analytics, and automation and orchestration. So in the users, it's about like authenticating these users and applying multi-factor authentication so that like they access before accessing it is verified, right? Even for the device, like we have like device management and checking the current health of the device, whether the patch level is okay or not. And at the like application and workload level, like so this is where we consider about the workload, so the containers, VMs, and so on. So we need to consider about the build of materials of those like resources. It could be like different dependencies you are taking from multiple locations and trying to build up your workload image, right? So that's you need to get an understanding of what is the security level of those build of materials. And the next thing is about data. So this is about mainly about like end-to-end encryption. And finally, like network. So basically, in the network segment, like in the traditional model, you had like very large network area, But in this particular model, we need to understand what are the simple or the small trust boundaries. So then you have to segment these trust boundaries so that you can trust is still maintained within the simple small trust boundary, but you have to still make sure you authenticate, authorize each and every request, use, and device. And finally, we need to have analytics. So basically, identify what's happening in your enterprise, and also we have the other pillar of automation. So when an incident happens, and how fast you can tackle this issue, how fast you can recover this, it has to be automated. So these are the 7 pillars that was published. And these are the tools and strategies that you can apply for each pillar. For example, the managing users, you have the identity and access management, privileged access management, multi-factor authentication, and least privileged access, different strategies and tools, right? When it comes to devices, you will see mobile device management, continuous detection and mitigation tools, and trust policy modules that is deployed into the device to make sure the authenticity of the device is not compromised, and then the patch management. And also at the network level, you have the segmentation, basically coming up with different segments to partition your entire architecture, and then the network level encryption. And when it comes to the workloads or the application that you develop, then you have to consider about the secure development patterns that I will mention. And then the continuous monitoring also important, to identify what is the patch level right now, whether you have to patch and roll out. And when you go to the data level, you have to first classify your data, whether they are sensitive data like PII or it's customer information and so on. And then based on that, you have to take a decision on the encryption. And also you have to take frequent backups, so use tools like data loss prevention tools, so that you have a higher understanding of how to recover if something goes wrong. And then from the visibility side, you need to have a network level activity logs and threat intelligence and so on. So I'm not going to details. But at a higher level, so those are the concepts that you have to understand when it comes to the zero trust. But now let's try to map this to a principle, let's say how it's working in airport environment, right? So assume in the airport, there was only one checkpoint where all the passengers, crew members and contractors are authenticated and given access to the airport. How disastrous it would be. They should be able to access to the planes, and they will go to the other restricted areas if we don't have multiple layers of security. So that's where the this segmentation of every zone is matters, right? So if you go one by one, for example, each and every identity is authenticated using different mechanisms. Sometimes you have the passport, biometrics, and then boarding pass, right? So these are the authentication mechanisms they employ. And also consider bag checking tools or whatever the scanners in place. If these are vulnerable, then the security of your airport is compromised. And then the next thing, the key important point of segmentation. And basically we have the airplane, boarding gates, and even the restricted areas. For example, air traffic control places are 3 different zones. So not each air and everyone can go there. There's a different authentication authorization in place to make sure only the allowed people are allowed can go there. And also the other points basically encryption of the protective data and allowing it only for the allowed people and are also in place, right? I'm not going further with the other details, but let's take another example in Choreo. So how Choreo has implemented some of these zero trust architectures. As usual, all our application or the CLI is again authenticated through Asgardio, and as of now we haven't make multi-factor authentication enabled, but it is supported for the selected organizations as they wish to continue with the high security options. And then we have built set of features. For example, what Choreo does is let you to deploy certain workloads into Choreo, And then each and every connections, network connection they make from these applications are monitored. And then we have the design time view. At the development time, you know that you are going to communicate from component A to application B, and this is the design time connection. And then runtime also, based on the observability data we collect through Cilium, is also collected, and then you can identify what is the diff. If there's a diff, what that means is there could be a possible anomaly. It could be like a breach happening through one of your dependencies used in one of the libraries of your images and so on, right? And how we have applied the segmentation, segment in every zone is like we have the control plane, data plane, basically separation, as well as we have like critical and non-critical separation of environments. And also we have implemented cell-based architecture so that the components are deployed in different projects are properly separated. So assume like there was a vulnerability in one of the component deployed into a project, like due to the fact that we have ingress and egress control in place, this particular application will not be able to even upload the some sensitive data out of this project to another external world, right? And we also have the SOC team working with us, continuously monitoring what's the situation of the basically control plane, data plane, and if there are any things they will detect it and get alerts. But it is not automated to basically correct it. We need to have a precise control there. As a result, we will have a quick meeting and try to address it. So these are two examples, the airport and the how we have done it in Choreo. So with that, I want to move on. Let's say if you want to implement this in one of your customer location or maybe any of the deployment, these are the 5 steps that you have to follow. The first thing is you need to identify what are the data or the assets you need to secure, right? Without that, you cannot go in a iterative approach. And then you need to understand what are the data flows, who is going to access these data, from where, and what is the severity of this data. And then you can define the policies so that your enterprise resources are secured properly and based on the priority or the severity of the data. And then you are going to incrementally deploy these policies and make sure you start practicing zero trust policies so that only at the time of granting the access, you verify all the available state of the system and decide whether it is allowed or not. And as usual, you have to keep on monitoring and then adapt and then keep on this practice until you cover all the data, all the priority data, right? With that, I'm trying to come to the end of my talk. So this is about I assume you get at a very high level of understanding of what zero trust is. So as a company, as developers who are developing CLIs or microservices or basically products, or it could be a DevOps engineer who is trying to take a backup of a particular certain application or a deployment, or it could be the security team is basically handling these events, security incidents. Knowing these technologies helps you to basically avoid vulnerabilities. For example, if you when you are designing the products, you need to look at the architecture level. You have to consider these facts. You need to know what are the data you are going to use in your microservice, or what you are going to store, where it is stored. We classify them and then apply encryption capabilities, and then also consider from where this data is moved from one location to another, whether that particular network is encrypted or not, applying of TLS or MTLS. So all are things you have to consider when you are designing these microservices. So even couple of years ago also, even our understanding was okay, this is deployed in this particular trust boundary. So we can assume that it is a trusted zone, and you are trying to avoid applying very strong authentication and authorization policies there. But with this principle, you cannot have the trust anymore. So there are internal threats, and you have to always assume there's a breach. So with that understanding, and if you have that understanding, and if you basically believe it, then you are going to like apply all the required like security enhancement or the security policies and practices to make sure your data and the resources are secure, right? So if you take the example of a SRE engineer like taking a backup, so you can take a backup and keep it without encrypted, right? And maybe you will forget it, and after some time you will end up with a severe vulnerability saying like somebody got access to that file system, and there was a like unencrypted backup. Now what happens, right? It could be LDIF, who knows? And then when you are design system, you have to make sure like the systems that we develop also like responsive for attacks. For example, in certain cases, we should be able to shut down one of the component if it is compromised in an attack, and then make sure the rest of the system works resiliently. So those are the other aspects as for the developers we have to consider when we are like basically honoring the zero trust architecture. And also, you have to know that the observability is your friend. Like, like what's happening at runtime, and then you can like look at what is available, like data available in the production with the help of SRE team, and basically plan and basically keep on continuously improving your like applications and products. So with that, what I want to highlight is like as engineers, as SRE team, as solution architecture members, at every stage of this journey, you can help to like improve the security posture of WSO2 organization, as well as our customers who are trying to deliver digital businesses. So with that remark, so I'm trying to end my talk, and thank you very much for listening.